The second order Taylor polynomial, P2 of x is equal to a plus bx plus cx squared, correct? Mm-hmm. What's P prime? Can someone tell me what the derivative is? What's the first derivative going to be? B plus 2cx. And what's the second derivative of this going to be? 2c. They tell you that that's a quadratic, correct? And you're doing it around x equals what? What does it tell you you're doing the Taylor polynomial around? 0. Around 0. You're doing it around 0. So look at that point right there. Let's look at the point where x is equal to 0 right there. At that point, what can you tell me? At that point, what can you tell me about the slope of the tangent line? So we know that f prime at 0 is going to be less than 0, right? This is P, it's P, sorry, P2. So what do we know? We know that P prime of 0 has to be what? Less than 0. So that means that B plus 2C times 0 has to be less than 0. So B has to be less than 0. What can you tell me about the concavity of this thing? Concave down, right? So that means the second derivative, P2x, has to be at 0. At 0, what does it have to be? Concave down means the second derivative is less than 0, right? So 2c has to be less than 0, so c has to be less than 0 because of concavity. Concavity.
You said it was the first derivative.
The first derivative is negative and the second derivative is negative. Oh, there, thank you. Yep. And I can change this. P2 prime is. Makes sense? Concave down and the tangent line is pointed down. Jared, yes? For x near 0, so it uses this, nice, to explain why the limit of as x goes to 0 of sine x over x is equal to 1. So what could you do if you're going to explain this using that approximation? What could you do? Where could you plug that in? Yeah, into the right-hand side of the limit. So it's x equal to 0 of what? X minus x cubed over 3 factorial all over x, correct? So what's that going to be? The limit as x goes to 0 of x over x minus x cubed over 3 factorial over x. Do you agree? I'm just doing algebra right now. So what does that simplify to, Chip?
It simplifies
to? Nope. Wanting to say it, what is that limit go to? 1. There it is. You got to do the algebra first and then do the limit. Do the algebra first. So we use that approximation and it comes out to 1, which is pretty cool. It's not a perfect proof because we're using approximation, right? But you could actually do the general case because what could you plug in? What is sine of x? Do you remember what sine of x is? You got to remember this one. What is sine of x? What is it?
0 plus.
Yeah, you can stop. You don't have to say the 0. What's the first term? What's the first one?
Sine.
What is it?
Cosine.
No, just x. X.
Yeah.
Plus what? Or minus? Minus what?
0.
X cubed over 3 factorial plus x to the 5 factorial minus. Do you agree with that? That is sine of x right there. I showed it to you briefly yesterday. You have to memorize it. You have to memorize sine. You have to memorize cosine, e, and a few others. But those are the big 3. There are several others, but those are the big 3. Here's the thing. Could we do the limit as x goes to 0 of this whole thing? Sure. 3 factorial plus x to the 5th over what? Minus x to the 7th over, like this. Just dot all over x. That's the general form. Do you agree? It's very similar to what it's x. Good. So now when we do this out, what does this become? The limit as x goes to 0 of what? 1 minus what? X squared over 3 plus x to the 4th over 5 factorial minus x to the 6th over what? What do all of these go to? All of those go to what? 0, 0, 0, 0. So this goes to 1. What did you just prove? As x goes to 0, not infinity. Some people think I did that before and you guys didn't like that. You just proved that. Bingo. You just use BC calculus and Taylor series to prove that the limit as x goes to 0 sine x over x is 1. Cool. Sababa. Okay. Anything else from the homework before we move on? Anything else? Nope. We get to move on then. Polynomial. How many terms? N of them. Finite number. It ends. So what do you think a Taylor series is? Same thing, just the only thing you add on to the end is plus dot dot dot. That's the only thing that changes. It ends for here, but it doesn't end for the series. So let's do something fun. I think it's pretty fun. I think it's pretty fun. What's the only difference here? That's a Taylor polynomial of degree n around what? A instead of 0. You like 0 because you like plugging in 0 into things. You don't always get to do that though. Okay, so I think we did this yesterday. Do you remember this? F of x equals ln x near 1. Why did we do it near 1 instead of 0, Ian? Yeah, and do you remember what this was? So we did it around 1. We turned this into, so ln of x was going to be equal to what? Do you remember what it is? Yeah, it's x minus 1. Yeah, do you remember? Yeah, it's x minus 1 squared over 2 factorial. Then what? I think it's, is it over 2? Well, I'm going to say 2 factorial. Can I say 2 or 2? It's 2 cubed over. Did we do this yesterday? We didn't do it yesterday? I thought we did. Okay, ready? Did we? Check your notes. I thought we did. Sometimes it's very hard for me to remember because I have 2 classes. So when you write the general term of this, you might end up with something that kind of looks like this. You have the summation n equals 0 to infinity of something. Oh, it's frozen? Yeah, okay. To, what do you get there? You get something like x plus 1. If you start at 0, what is it? It's, anybody have it? What's the nice term? So what if you wrote this out, what did you get? Let's just write it out this way. ln of 1 plus x ends up equaling what? X minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4, I think. Is that what you end up with? Right? What? Correct. But to run the ratio test, you need to write the explicit formula. So what's the explicit formula going to be? The sum of what? It's negative 1. What do you want to start? You want to start at 1? Okay. To infinity, to the n plus 1. Does it really matter which one? I can do n minus 1. It doesn't matter.
I think he dropped factorial.
Yeah, well, he dropped it because when you simplify it, you end up with, on top, you end up with n minus 1 factorial, and on the bottom, you end up with that. What does that equal? That's 1 over n. That is 1 over n. So there's this, and it's just times x to the n, right? Right? So then you run the ratio test. You run the ratio test. Everybody remember the rate? We've done this many, many times. You run the ratio test, and you might end up, you do the ratio test, and then you end up with this, negative 1, like this. But then what do you have to test? You test the endpoints in order to find the actual interval of convergence, because you're not done until you test the endpoints. So if x is equal to negative 1, what do you end up with? Negative 1 minus a half minus a third minus 4th. What is that? It's the opposite of the harmonic, which what? Diverges. But then if you plug in 1, bless you, you plug in 1, you end up with what? 1 minus a half plus a third minus a 4th. What's that? Alternating harmonic, which does what? Converges, okay? And so that means what's our interval of convergence? Our IOC is going to be soft bracket to closed bracket, negative 1 to 1. What's the radius of convergence? 1. Nice. Okay. So was this is a healthy amount of work, right? Do you agree that this is a healthy amount of work? Let's take a look at something I clipped up here briefly a little while ago. We were looking at, where was it? It was right here. Remember this? Remember what this was? Let's go back down here. We did all this work right here. Where was it? Let me go right over here. What was this? Do you remember what this was? That was ln x around what? Nope. Around 1. Do you agree with that? That's what we figured out before. We had that already, right? Is everybody with me? And also, we actually did the interval of convergence on this. Do you remember what the interval of convergence is? It was 0 to 2 hard bracket. Do you remember that? I'm just telling you if you don't remember. Okay, what's the difference structurally between the graph of ln x and ln of x plus 1? What's the only thing that changes? It shifts 1 to the left. Do you agree? It shifts 1 to the left. So what happens if we just substitute x plus 1 in for x in all of these? What happens? ln x plus 1, and what do you get on the other side? X minus what?
2.
Not 2.
0 over 2.
X squared over 2 plus x cubed over 3 minus. So if you are trying to find the Taylor polynomial for a function that looks really, really similar to one you know already, like sine, cosine, or e to the x, what can you just do instead? Substitute. If you know this is true, which I'm telling you it's true, what can you substitute for x? Oh, x plus 1. And you just move the interval 1 to the left. What was the interval of convergence before? 0 to 2. Move that 1 to the left. What does it become? Negative 1 to 1. Is that a lot quicker? Yeah. So if you memorize some of these Taylor series, does it make things easier for you? So what are we adding there to it? What do we have now? Sine of x is one you have to know. What else do you have to know? Cosine, e to the x, and what? We also did this one, 1 over 1 minus x. That was a nice one. So we'll add that to the list. Okay, everybody stand up and stretch for 5 seconds. Stretch for 5 seconds. Stretch, 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 stretch. Stretch. Okay, sit down again. Thank you. Have we ever done that before in Algebra 1 or Algebra 2? Stretch, you're like, yeah, maybe we have. You've done this before, right? Please say yes.
Yeah.
Foil, like the opposite of the first, outer, inner, last, multiplying out, right? And then maybe, like my calculus class had to do, cubing, so you end up with 1 plus 2x plus x squared times 1 plus x. Does this get a little tedious? Like if I asked you to the 7th power, could you do that? Yes. Would it be tedious?
Yeah.
Absolutely. So let's look at something here. Let's say I had, call it j of x equals 1 plus x to some power p. With me so far? Yay. What's the derivative, Soma? To the? Yes. Wiley, what's the second derivative?
P times p minus 1
Yep.
times 1 plus x.
To the?
P minus 1.
Yes. Let's just do one more. What's the third derivative? Annie, what's the third derivative?
P times p minus 2, p minus 1 and p minus 2.
Times
1 plus x.
to the?
P minus 3.
Okay, are we okay with that? Now let's say I wanted to plug some zeros into there. This is where it gets fun. Please be careful. It's not a trick question, but you guys are just really sometimes not going to like it, but that's okay. Let's say I asked you, what is j of 0, meaning plug in 0 for x. What do you get? What do you get? What is 1 to the p? 1. What's j prime of 0? What is it? Just p. Because what is this? What is this always going to be if you plug in 0 for x?
1.
Those are always going to be 1. Do you agree?
Yeah.
So what do you end up with p? And then what's j double prime of 0? P times what? P minus 1. So what's j triple prime of 0? Watch out for the chord. P times p minus 1 times what?
P minus 2.
Okay, are you with me so far?
Yeah.
What was that general form of a Taylor polynomial centered around 0? What was it? So we know j of x can be written as j of 0 plus what? J prime of 0 over 1 factorial x to the first plus j double prime of 0 over 2 factorial x squared plus, oh, does this get repetitive? Uh-huh. And so forth. Are you okay with that? Do we have those values now? We have a bunch of them. So we know j of x is now equal to what? What is j of 0? 1 plus what? Plus just, what's j? Oh, just p times x plus what? Oh, but what is, oh, p times, what is it? P times p minus 1 over what? 2 factorial x squared plus p times p minus 1 times p minus 2 over. Could you continue this?
Yeah.
So what's the point? What's the point of having something like that? Well, I could ask you, Annie, what happens if I asked you to do, let's say, I don't know, 1 plus p to the third. So p is now 3. That's equal to 1 plus x to the third, sorry. So p is equal to 3. Plug in 3, what do you get? What's the next term? Plug in 3, plug in 3, plug in 3. What do you get?
Oh, so 1 plus 3p.
3x. You're plugging in 3 for p.
Plus 3
times
3 minus 1
2 over, there we go. Plus what? 3 times 2 times 1 over 3 factorial x cubed, right? Does this simplify?
Yeah.
1 plus 3x plus what? 3x squared plus x cubed, because they cancel, right? What would be the next term if I wrote it out? This goes on forever, right, theoretically? So it would be 3 times 2 times 1 times what? 0 over 4 factorial x to the fourth. What would be the next one after that? 3 times 2 times 1 times 0 times negative 1 over... Oh, what are all of those?
0.
Why? Oh, the zeros are there. So those all go away, gone. So what did we just show?
That's it.
That's it. 1 plus x to the third is that. This allows you to do binomial expansion really quickly. It's Pascal's triangle. It does binomial expansion really quickly. Now, it's still annoying, but it's a lot better than doing it manually. What do I mean? I could ask you now, what is this? 1 plus x to the seventh? That's going to be 1 plus 7x plus 7 times 6 over 2x squared. What's the next term? 6 times 5 over x cubed. Could you keep going? Yeah, 7 times 6 times 5 times 4 over 4 factorial x to the fourth plus 7 times 6 times 5 times 4 times 3 over x to the fifth. Now, am I ever going to ask you to multiply that out by hand? No, that's good. Yeah, I like the comp. No. X to the sixth. And what's the last term? 7 factorial x to the seventh, because it has to be x to the seventh. That's nice. But on the AP exam, they could easily ask you, okay, binomial expansion, they could ask you this. 1 plus x to the 13th. What's the coefficient of x squared? They could ask you that. And can you find that really quickly? Yeah, what would it be? 1 plus 13x plus 13 times 12 over... Keeps going though, right? And then they're going to give you A, B, C, D, and E. And the answer to this is 13 times 6, which is, someone be really careful with this, you're hitting this. What is it? Done. If you didn't do it this way, would that be a pain in the butt? Yeah. So you now can use binomial, you can use Taylor series to do binomial expansion. It's super cool. So we had another one here. What's another expansion that we now need to remember? 1 plus x to the... So you need to memorize these right now. Yay. Super exciting. I know, it's so much, man. So much stuff. It's so, just so painful. So here's the story. Tell me what sine of x is. Someone raise their hand and tell me what sine of x is. The Taylor expansion. We already talked about this. Anybody remember what it is? Anybody? Anybody? Shirley, what is it? X, yeah? Over. Yep. Over. Good. 7 factorial. Nice. That's cool. It alternates. Can anybody tell me what cosine is? Anybody remember what cosine is? Anybody? Yeah, what do you think, Wiley? You got it right? Yeah, you can look. It's okay. It's fine. What do you got?
1 minus x squared over
2 factorial plus...
x to the fourth over 4 factorial minus x to the sixth over 6 factorial.
Is that cool? Nice. What's the easy one? What's e to the x? Anybody have that one? What's e to the x? Yeah, what is it? Yep, plus... Okay, so what did I say before? If you wanted sine of negative x, where do you plug the negative x in? Into all those terms, and then you're done, right? So you can do direct substitution. Do you agree? So let's say I was looking at e to the x. Everybody with me so far? Let's say I wanted to do e to the I theta, some value of theta, like an angle degree, right? If I wanted that, where do I plug in I theta? In for x. So it's 1 plus I theta plus I theta squared over 2 factorial plus I theta cubed over 3 factorial. Do you agree with this? Be very careful now. What is I to the first? Well, that's just I. What's I squared? I cubed, negative I, and I to the fourth is 1. So what does this equal? 1 plus I theta, what? Minus theta squared over 2 factorial. Then what? Minus I theta over cubed over. Do you agree with that? All I've done is multiply out the i's. You agree with that? So what do we now have? We have this. You see that? Yay, exciting. We good with that? Let's go back up here and look at sine for a second. If I have a equals a, or a equals b, can I multiply both sides by the same thing? Is that allowed? Can I divide both sides by 5 if I wanted to? Can I multiply by pi if I wanted to? So is this true? If I plug an I right there, where do I have to put I? Everywhere else, right? Do you agree? Do you agree with that? Okay. And instead of x, let's say I wanted to write theta. Could I do that? Does that change anything, calling it a different name? Okay, so you see all those x's up there? So what does if I wanted to change all those x's to thetas, that would be allowed. Let's just take stock of something. Do you see the thing I highlighted in yellow down there? Yeah. Let's just take stock of something. I see a 1 there and I see a 1 right there. Do you agree? I see an I theta right there and I see an I theta. If I changed x to theta, do you see it right there? What about negative theta squared over, oh, there it is, right? And where's the next term? Sine. So what have we now shown? E to the I theta is equal to cosine theta plus I sine theta. Are you okay with that? This series added together to that series equals that one. Are you okay with that? Raise your hand if you're okay with believing that. So what theta value should I choose? How about pi? E to the I pi is therefore equal to cosine of pi plus I sine of pi. What's sine of pi? 0. And what's cosine of pi? Negative 1. E to the I pi is equal to negative 1. So what does that tell you? E to the I pi is plus 1 is equal to 0. You just proved Euler's formula. Sit down.